That's what I'm going for. Avoidance. So what does this mean? It means that I have a radius around me, and I'm gonna have to query for all of the other void entities within that radius, and then basically move away from them. And I wonder if I want to like move away from each individual one, or if I want to like somehow like take the average of each one and move. I think it's actually maybe a little bit easier to just say, hey, if I'm near you, move exactly the opposite direction that you are. And if I'm, yeah, I think that might work out. So I need a radius around me. So I need to figure out what that is. And it also sounds like I just need a system for avoidance. So I'm gonna create a new file in here. So we're gonna avoidance.rs. All right, so now that was actually a fun part, actually figuring it out and doing this thing. So we need to be able to query and get like a vector of all of the voids that are near me. And that's for each of these voids. So it's gonna look, so we're gonna loop through all the voids. And the only thing we're gonna update to mutate is gonna be the acceleration. So this is where the RC I think is gonna come in very handy, is that we're gonna be able to clone the locations several times, but then it's still the same location, still the same reference to location. So let's create this function. So pub function avoidance system. We know we're going to take in the world. Right, the world. Okay, so we have this type here. The two types for the world. What do you take in? It's the keys and the components, if I remember correctly, or the keys and the resources. I remember now. Where is my main library? Here it is. So we can see this right here. I kind of want to have a type in this. So I'm just gonna say type, this is gonna be like the world, I don't know what to call this, like the world type. Actually, can I do this? Like type world equals this entire thing, so wrap around it. And then you are a world. No, because like world is being like world is being overwritten here, so I would have to do something like world wrapper, like a world wrapper type. That seems to work. So I could definitely do this, world wrappers, then back into here in avoidance. I want to reference to world wrapper. Now I don't know, this doesn't feel good to me as a name, but I don't know a better one to use right this second. I don't think I'm going to return anything. So inside of here, what do we want to do? Okay, so we will be doing this by querying for all of the birds within visual like range of each other. then I guess like steering away. So then accelerating away from each of these birds. I think that's what we're going to start with. I'm not going to necessarily do like a stronger acceleration away yet, but like if we get too close and we start getting collisions, I think that could be something we look into. All right, so given that, we need our range that we're going to care about. So let range, like sight range. And I don't know what this should be. Let's just do like 50.0 for like pixels. It'll automatically figure out it's supposed to be an f32 as soon as we start using this. Then we have the location, so we need all the locations. So and then this is going to be a location. What is this called? This is the component names. Come on, tell me component names. There we go. Component names, locations, location. So we query for that. That gives us this RC ref cell. I need to get inside the ref cell. We only need to borrow it. That gives us a ref, but then with the vec of components. So we're pretty much ready to use this now. We can now loop through all of our locations. And that's kind of what we want to do, is loop through all the locations, then for each one, do our thing. So locations dot iter. We will need the enumeration. And it's locations dot iter. That for each, we need to enumerate to. All right, we're gonna get a look index and a location. All right, so now we have that. What do we need to get? I need to get all the other locations near me. So if I need to get all the other locations near me, how am I going to do that? I know the index of me, so I can compare against like another loop through. That might be good here. The other thing is, I don't think I want to borrow here. So I just want like all the locations here. We can maybe like borrow here. And we can, that means we can also clone you. So by cloning this, I'm cloning the RC. What are you upset about? Mismatched types. Oh yeah, reference. What are you upset? Oh, because I forgot to. I keep on forgetting to close that because I keep on thinking it's gonna create a new one for me. Okay, so here we go. I'm gonna clone the RC, which gives me another, like basically now I have two read views into locations, which is perfectly fine. RC allows me to do that. It's read only. I can't update locations, but that's fine. I'm gonna update acceleration. So we know we're gonna need that. Let's go ahead and get that. So accelerations, world.everyone. It's a reference to acceleration. And in this case, we should just be able to borrow this straight up. We can just borrow mute right here. So we got a ref mute there, and now we can update it. We can do our we could do whatever we need to off of this. For our locations, I need to get all the other ones near me. And me, I'm thinking about like the individual Boyd. So we say, okay, here we are. We're this one, like, one individual Boyd or bird, and how many are like nearby me? So I need to query that. What I can do is loop through again all the locations and get like is near me. So we need the distance between two different vectors, really. Well, to get that, I can subtract one vector from another. And that gives me the difference, really. Like just the vector between 2 points, which is perfect. Because then I can get the distance, the length of that vector, or point in this case, and check to see if that is greater than or smaller than this. All right, so what is our plans? We need to for other voids, so for every other bird, we want to get their get the difference. So get the distance point, measure how long that point is. If that point is less than our sight range. So if it's less than our sight range, I want to move away from it. Move away from the other bird. Otherwise, we don't do anything at all. So for every other bird, it should be like fairly simple. We have our index, so I can do another loop through. We can clone locations again, loop through them, and I'll get the index again. I can just ignore the same index. So that's what I want to do here is we're going to do locations.clone again. Then we can get another borrow. We can get an iterator and enumerate. So we have the index, so we know which one it is. And then we have another for each. And so this is going to be the other index and the other bird. Okay, so then you all go inside of here. Now we need to get the distance point between here. So this is going to be a little bit interesting. We want let's just, we'll probably have to, yeah, so let's say distance is equal to, we're going to start with like ourselves minus the other. So it's our location. And I want to do basically minus the other bird. Oh, and we need to cast. We do need to cast. I forgot about that. We should cast once for mine. So that my location is equal to location dot cast point. So we have my location minus. Now I think what I can actually do here is do the dereference little trick. Maybe I have to look into like what we need for that. So let's figure out the minus thing. No errors in here, so that's good. Also, you ruined my tabs. Thank you. Here's point. Let me try impl. Is it subtract? The subtraction operator. So sub for point. Yeah, so it takes in ownership of self for this. So I need to like clone the other, which I mean isn't too terribly bad, but it also like kind of sucks. And type output, can I say like type output equals a, it's gonna be a new point. It has to be a new point. So it's basically just gonna be self. So then here it would be, we want to do self. Why are you upset with that? I want to return self with a capital S. X is equal to self.x minus right-hand side.x. Y is self.y minus right-hand side.y. Okay, that makes you happy now. Back to you. Get the distance point. So this is going to be let. Oh, we already have that. My location minus the other bird. But we have to clone this. Now, what I can do also is come up to here. We have this clone. We can implement copy as well. I don't need this clone anymore. It'll auto clone. And that will give me point, mismatch types, have to destructure. There, and that gives me that. So now I have distance, which is a point. Wait, what? Oh, wait a second. Found enum components component. What? Oh no, I thought, oh wait, I forgot. I need to cast, so dot cast point, that. Okay, there we go. That now gives us our distance, which is a point. Our distance is a point. But now we can get how long that distance is. So that distance length you can't figure out what that is. Do I have to dereference you? Oh, type. Okay, wait. You do know what type that is. Why won't you tell me? All right. So now we have measured how long this distance is here. If that point is less than our sight range, so if distance length, if that is less than this sight range, we can now, oh, you haven't updated yet. still don't know that you're supposed to be an F32. I can't help but feel like either I'm doing something wrong or Rust Analyzer is not able to follow with this. But okay, if it's within our fight range, we want to now move away from the other bird. So what does that mean? I want to take this other bird's location, and I want to create a force that's exactly the opposite. Moving away from that, and I think, let's see, how do I get the exact opposite? So if we come back to here, hello, Peyton Rules. When you're not trusting Rust Analyzer, you usually run a cargo build and cross-check the results. That's actually a really good idea. Let's see if I can just run a cargo build here. I mean, so it builds. It wouldn't build if this literally wasn't allowed. So therefore, it must be good. And Rust Analyzer is just not happy. So like this is an F32. Rust Analyzer doesn't know that. Thank you, Rust Analyzer. Okay. I wonder, do you need to update? Usually it's like updating at the like tomorrow or Tuesday. How can I tell, like, force it to update? I don't know if I can like force an update. I can reset. Restarting the server sometimes does it. No, you use Emacs. Like here, it's just usually an auto as soon as like load up VS Code, and I have been quitting VS Code between each session. So yeah, look, like all these. Oh, now I don't even get these hints here. Oh, that's fun. Okay, so you are an F32. And you know, can I tell you, is it possible for me to tell you that you're just a self? Can I just do that? And not have this type? No, it needs the output. So if I do that, let's see. Raycat, who dat? Hello. Let's see. Move away from the other bird. So I now need the opposite. So let's go take a look at like what the math for this would look like. So if we have something like a 5 and an 8, what does that look like? That is forward and it's down a little bit. So that looks a little bit like this as a vector. So if I want the exact opposite, I want this. That's -5 and negative. Yeah, because like it's just reversed, right? It's just a -5 and -8. So I just multiply by -1 and that gives me what I want. I'm not sure I like this pattern though of using the these impls, because it's screwing up Rust Analyzer, and I'm like, I think I would rather just put it in here. Sono Luhani, hello. Font I'm using I am using JetBrains Mono with ligatures on. With ligatures. The ligatures give me interesting, nice things like this arrow that actually looks like a real arrow, or these like not equal signs. Okay, so I need to multiply it by -1. Now we have this multiply scalar, but this like self-assigns. So I wonder if I want to like reset this and like have something else that it doesn't like mutate. If I follow the idea of how like processing does it and like the interfaces they have for vectors, it would end up looking like this. We're gonna do multiply two points together and return a new point. So then the way this would work is 1 equals new 2 and 3 0.2 equals point new. Let's do like 3, 0, and 4.0. Let result equals. The way we would do this would be like point multiply and then pass it in 0.1, like a reference to 0.1 and a reference to 0.2. And this result is going to be a point F32. I guess it's going to be a point. I don't know if I need to say that. And then we're going to assert. There's going to be several assert equals here. So assert equal that result dot x. I guess we could just do this. Result dot x is going to be equal to 2 times 3 is 6. Result dot y is equal to 12. Okay, so we're going to do multiply. Function multiply. Do we have static methods in Rust? Yeah, sort of. So like, I don't think they're called static methods, but basically they're methods that are on the struct itself, as opposed to like objects spinned off from the struct. We can see actually I have new here, and this would be like, I'm going to follow the same pattern. The only difference to tell Rust that this is something you call directly off of the struct is the lack of a self. So I'm going to have two points. So we're going to say point 1 is a reference of self, and point 2 is a reference to self. And we're going to return a new self. So it's just another way to create another point. So we're going to say self x is going to be 0.1 times 0.2 dot x. Can't forget the dot x. It's going to be 0.1 dot y times 2 dot y. And so this should work here. And this documentation is now like an actual full. See, why choose this way over having the point accept self and one other point? I can do that. What I was thinking, like, I need a way of like what mutates self and what doesn't mutate self. So I'm choosing this way to be consistent, whereas the ones off of a point obviously can't mutate anything. And then this, like normalize, multiply scalar, they mutate self. So in this case, I don't want to mutate self. That's the reason why. There may be a better way, like communication wise, to ourselves. But okay, so I want to move the other so I need this new point. So let's see. This is gonna be our this is gonna be like our force equals the other bird dot. Oh, right. It's oh, wait a second. I don't want it to be multiplied. I need to multiply by a scalar. That's what it was. I need to multiply scalar that doesn't. Well, I'm I don't really need this. I just realized a better way for me to do it. What I could do here is let force is going to be our other bird. We're going to clone it. We need this other bird. We need to cast the point. So let's just cast it up here. So we only have to cast that once. So that other bird is equal to other bird dot cast point. So that gives us this reference to a point. I want to take other bird. So we don't need you anymore. We take other bird, and then I want to clone it. Then it gives me a brand new bird. And then I want to multiply scalar by -1.0. That will reverse it completely. So I don't need that entire other method. I can just do this. Now, what are you upset about? Expected function, points. Expected function? Oh, wait, yeah. Why do I have that? I don't need it. Yeah, I don't like this pattern. I don't like this. I don't think I'm going to do that anymore. I should probably undo this too. Okay, so that gives me a force which you can't figure out what you are. You're a point. We cloned a point. And then we multiplied scalar. Oh, got it. We need to do this in 2 lines. So here we have this point, and then I say, it would be mutable force. I'm going to say force dot multiply scalar by -1.0. That's what. Okay, so now the force is reversed. It's backwards. I probably don't want it to be moving exactly the same speed. I want it just like a gentle push. So let's normalize it. So we're going to do force multiply scalar. So that's another function I created a little while ago. That's this right here, multiply scalar. This mutates self. So I now have this force. Let's now normalize it. So force dot normalize. Normalizing Normalizing takes, so if this is the vector, then it takes this line, the hypotenuse, and makes it 1.0, and then divides by each of these appropriately. So it basically makes it very small. Maybe you want it to return self instead, just because the way you try to use it. Oh, that's a really good idea. But do I want it to return ownership of self? I could have it like return, like I wonder if I did this, if I mute self, like if I just did this here and return self, it didn't immediately tell me that everything is broken, but what that does do is, can I now do a dot multiply scalar negative 1.0 like that? We have a mutable reference to a point. I want to say though, it's going to yell at me that temporary value dropped. Yeah, it's going to drop. So I need ownership of it. Yeah, I would need to rethink how this works. I think there's a way to do that potentially, but that's going to be like very similar to the problem that I have right here, which is everything is being cloned. Like it's just cloning things constantly over and over again, which is suboptimal. I should look into vector 2, like how an algebra vector 2 does that. Okay, so back to here. We've normalized it. Now I need to scale it by some amount. So we're going to do a force dot multiply scalar by some amount. So I'm thinking like 0.1. I'm actually really curious. My handle arena edges, I'm doing this 0.1. This is like my turning strength, is essentially. And I may want to like put that into a resource and share that around. I don't know. I mean, the other thing, I think like what Peyton, what you're getting at is I could do like force where I create the force right here, and then I do force dot multiply scalar dot normalize dot multiply scalar and do all those together. That would work, because then it wouldn't be losing force after the first one. Otherwise, it's just going to hit the clone and copy constantly, which sucks. All right, so we have we've multiplied the scalar. Okay, now we need to apply this force to the acceleration. And that's right here. We just need to add to the acceleration. That's it. Just add to the acceleration. So we have borrow mute. It's the vector of component, so accelerations. So we can say accelerations of index Sometimes it feels like I'm doing clone and copy so much, I'm just pretending I have a garbage collector. I know, I feel that way too, and it's something, if you're just starting out with Rust and you're learning it, I would suggest just clone and copy everything. Like, don't worry about like optimizing the heck out of stuff. Just like clone and copy, clone and copy, clone and copy. It will also show how good the compiler is at like making things fast and optimizing, because it's not as bad performance-wise as you might think. But then as soon as we start hitting those performance walls, and you start getting like a feeling, oh, this is the area where cloning and copying is the problem, and this is the area where it's not a problem. Then you can start like actually optimizing when it's a good idea. Now in this case, I'm planning, like, if I could have like 1,000 of these voids, I would. And so cloning and copying might not be the best idea if I have 1,000 of them. That being said, I don't know how bad it really is, because cloning and copying like F32s is not a big problem whatsoever, and a struct isn't really taking much space up on its own, so it's a very simple structure. Yeah, there's a couple tools for like determining where slowdowns are occurring, but I think like those are still like being built, like that's being optimized. LLVM has some tools too that you could use. I don't know how helpful non-Rust specific ones are, but I remember seeing on a Reddit post on the Rust subreddit about a really cool tool you could just drop into a crate and it just gets faster. Or no, it doesn't get faster. Sorry. It measures how faster you can make it, like where the slowdowns are. And it creates a nice little graphs for you, which is really cool. I haven't used it yet. Okay, so accelerations.index, we want to get into there, and then we want to get this acceleration. So is equal to this. Now this is that specific component. I don't want to own you, so I want like a mutable reference into this component, and then I want to cast up point mute. So I guess I don't need to do this. That gives me a mutable reference to the point. Then I want to add, so acceleration dot add, and then the other, which is going to be our force. So I do have an error. Oh, right, because I took you off. Okay. So add, you need a point. Oh, you need to be a reference to a point. Accelerations. Okay, so cannot borrow accelerations as mutable. So up here, we need to tell you, hey, you're mutable. All right, no errors. That's a good sign. This is pretty nasty. But we have their avoidance system. Let's come back down here to update. We're gonna handle the edges. We're gonna handle, let's see. Then we're gonna do the avoidance system. Pass it in a reference to self.world. There we go. Let's try running this. I can't help but feel that that's not exactly what I had in mind. Yeah. Everything was moving with each other. That's like the opposite. Okay, so what happened there? Previously we had like a bunch of voids. They start together in the same exact spot in the center, and they all move around. I wonder if having them all start in the same exact spot is a big, huge problem here. I wonder if like that's causing us weird issues. So what if I in the beginning here, so in our main library, Here's we're creating, like, we're responding all the voids. Let's give them random locations too. So we have this point X here. I want to do a random. Oh, I wonder if it'll figure out what it needs. Probably not. We can multiply that by the scale of like the arena with arena size dot x. We want you to be here too. So this can be random times arena size dot y. No field on type. Right, it's 0 and 1. And you do need a type, don't you? Yeah, you do. Okay, so you can't auto figure that out. 32. There we go. So if I do this, everything should start in a completely random spot on the screen. And I wonder if that's going to change the behavior. What did I do? That was weird looking. Let's see. In avoidance, I wonder if this like 50.0 is like way too large. What if I do something like 10? They're all moving to the top left now. Every single one is moving to the top left. And to show to myself that I'm not absolutely insane, just partially insane, I'm gonna take off this avoidance system. We're gonna remove it. And everything is working still the way we expect it to. So definitely something weird going on there. Okay, what did I do? Everything is moving up and to the left. You know, I am not checking with myself. If so we can only do this if Toggle Bed, hello. Am I doing voids? I am doing voids. The voids are really bad right now. They here, I'll show you. It's kind of hilarious. Here's my voids. This is what happens when I tell them to avoid each other. They do the exact opposite. They just move up to the top left corner and they're like children. They don't listen to me. They have smooth movement. That's a thing. Okay, so oh, you did voids with rest with an ECS too. Nice. I'm not touching you. I'm not touching you. Yeah, that entire thing. I do not miss that part of childhood. Are you basing this on nature of code? No, I probably should. I'm doing this based upon just my own thought of how it should work. I never got that far into nature of code to get to voids. We did a bunch of nature of code on this channel, and I've even got some requests to like continue on because there's some really cool things that are happening later in it. So maybe that'll be something we can do. But I have so many project ideas they want to work on. All right, I need to make sure I'm not avoiding myself. So if my index is equal to the other index, I want to do absolutely nothing. So can I, in a for each, can I skip? I can just do like a return, an early return. So if I do that, how does this work? Suddenly a lot better. Although I'm not really seeing much in a way of avoiding each other. I still see them passing over. It does look like they're kind of sort of. So I want to update this multiply scalar. Let's do like to 0.5. And let's update our range again to like 25. You're able to use it in a game jam when it's done. What? Wait, what? Fucking hell. What did I do? Why? Okay, so sight range. You're back to 10. We're gonna keep the multiply scalar here, which is the avoidance force to this. I need all three of the behavior. I'm just doing avoidance right now. I'm just trying avoidance. Because I've seen people do avoidance with nothing else and it's worked. Okay, they're trying to avoid each other, which is a really, really cool, good thing. That's great. That's actually really cool to see. Okay, but Quadabot, you had asked, I'm able to use this in a game jam when it's done. So technically, yes. Theoretically, it may be a bit hard because I'm kind of like setting up the ECS system, like the library that I'm using for like the projects I'm working on. So if you end up working on something that doesn't exactly like you follow the same sort of like patterns or the idea that I have, you might run into a little bit of trouble / frustration. Which ECS did I go for? BB ECS. BB ECS doesn't exist yet. You probably haven't heard of it because I wrote it myself. And I haven't yet published it up to crates. So BB ECS is this library right here. I have a world, I have some components and resources. So I am trying to write my own ECS system from scratch. And it's been a very big learning, like a learning resource for this. You like BB ECS because you know where to find the author. Yes, you do. And like we're in a couple different discords together too, so like you can even yell at me and in one of those places. All right. So I think the avoidance is working now. Hold on. Where am I? You back and want to launch you again. Like everything's trying to avoid each other. Now they're a little bit they allow themselves to get a little bit close together. So, how big are they? Okay, make you go away. So for this bird mesh, your radius is 5. That's 5 on each side, so that's 10 total. And for avoidance, our radius is 10, so like exactly the same, which means there can be a little bit of overlap. What if I do 15? So like getting closer to each other, but not exactly. So 15, hard turn. They're like bouncing off of each other. Okay, so if I grow you, what? If I make you like 25 again, but we reduce the amount, it's like 0.25. Cut that in half. Will you look better? They're sort of like in this. Some of them are escaping, it looks like. Huh. So that's not. It's not what I was going for. I wonder if I need to like actually just go for broke. Just say like, okay, we're 50.0 and we're like 0.1. They all end up going in that like top left. Well, a lot of them do. Some of them like escape from like the big like jam, but do I have too many voids on the screen, like this small enclosed space? Do I need to make you like 100? Ha! No, I think, okay. So for each of my locations, I get the other location. So I have the other bird. So I have my location and the other location. If it's not me, so if it's not me, then get the other bird. It's really the other location. So we cast that into the point. Hello, it's B. It looks like your calc just produces a force vector based on the inverse of the position of the bird. Yeah, you're right. I think that's my problem. Okay, so I get my distance, which is really the direction like slash distance. So that's my other location minus location. I need this distance. I want the distance, I think, to be the cloned, because that's like the direction of like how like the actual arrow getting to them. So if I do like that distance and I reverse that, that's the opposite direction. So let me try this. I mean, it's cool. It's... What did I do? That's the opposite of what I wanted. It's something. Direction is backwards by the look of things. Okay. I always like I've never really understood which one I should be subtracting. Like, how do I know which one to do? So if I do like other location minus location, if I just make that change. Oh, my location. Look at that! They're avoiding each other like champs now. Sort of. Some of them are still sort of running into each other, but they're trying. They are trying. So, okay, let's... We got this 100 when they're like aware of this. If we go back down to like 50, but we increase you by 0.1, and I run this again, will they do better at avoiding each other? Yeah, sort of. If they're moving too fast, they don't have time to really truly avoid each other. They just still hit each other. I could try like the 0.5 and then back to like 100, and then they're steering away from each other farther away. Okay, so my direction is you minus me normalize. You minus me. Okay. Now they're a little bit too shy. Like, we're now in social distancing world. Lampi with rating with a party of 6. Hello, 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 Lampi and Raiders. Welcome, welcome, welcome. How's your stream, Lampi? Also, I have no idea if I'm pronouncing your username correctly. Release. We're gonna play the raid, the get the streamer game, which is we do every time we have a raid. But yeah, Lampi, how was your stream? What were you working on today? It's like Lempi or just pie. Oh, Lempi. Oh, got it. Okay, Lempi. Got it. All right, I'm gonna try to avoid all the stuff that you're gonna send down. Oh, thank you, Togglebit, for the... Oh, well, you didn't try. You just did a random. You actually weren't trying to help me. But I'll take it. But yeah, this is a game we made in Rust and GGEZ. I know, it's just you and me now. And you can only send out so much stuff at a time. Oh, no. You got more now. Run away. Ah, okay. Oh, this is fun. My my iPad, which I have to admit is an ancient iPad, so it's like, you know, not that great. It just told me right now, Lempi, that you went live. Which is for perhaps a little bit late. Stream was great. You did compiler dev in C++, but you stream Rust sometimes too. Well, awesome. Compiler dev, like, are you like working on the C++ compiler, or are you like making a new compiler in C++? Either way is pretty cool, pretty advanced stuff. I'm not, I don't, like, that's more advanced than I can do right now. Yeah, I won. Sorry, Quadabot, just a tiny bit too late. A compiler for your own language. Just happen to use C++ for it. Nice. Nice. Well, what we are working on today is a custom ECS library, and then a flocking simulator, sort of like void simulator, to use that custom ECS library. Right now, I'm trying to get all the voids to avoid each other, and I've got like maybe a little bit too good of avoidance here. So if I move you at like 0.35, I'm trying to like, nope, that's the wrong. It's the wrong game. I want to come back to you and cargo run here. They're sort of like trying to avoid each other for like a little bit too far away, which is cool. They're doing a good job of avoiding each other, but I need to like play around with these. It's like 65 maybe, and like find the right numbers where it looks appropriate, where they're avoiding each other, but they're also close together. It's like this is a little bit better. You're gonna go now, have some things to do. Awesome. Well, Lempai, thank you for the stream. Thank you for the raid again. Have a great rest of your day. And yeah. And then Togglebit, you redeemed Pet the Kitty. I don't know if Zilby. Hi. You want to come here? I have a ball for you. He's in the back room. I'm gonna go grab him really quickly, and then we'll do a pet the cat. You can look at the voids in the meantime. Absolutely. Well, hello, kitty. Do you want to go? You're high energy right now. Oh, you want me to throw you? Okay. I don't know if I can do this. Let's see if I can do cat cam. Can't pet the voids? Yeah, that's true. Cannot pet the voids. All right, so if I do cam down here like that, what do you look like? Not. One wire. Sort of in that direction. Lily, come on. You wanna run? So we'll see if he comes back with the ball. He sometimes does. He sometimes does not. He loves playing fetch. It's actually surprising because I've had some cats in the past and they didn't care at all. Like you threw something and they're like, what? You think I'm a dog? No. I'm not gonna go fetch that. But here he's pretty good at that. All right, for these boys, I want them to get just a tiny bit closer together. So let's try 50 again with the same turning radius. Try you again. Yeah, look at this. Okay. They're willing to get closer together. You never heard of a cat that plays fetch? So I saw some YouTube videos of cats playing fetch. I think like Rachel and June from Rachel and June's Adventures, they were able to play fetch with like Haku, I think, one of their cats. But that cat is, what's the type? It's the giant cat, the one that like people claim are like dogs essentially. They have a much more like human centric view than like most cats do. So they can play fetch, and they're very smart. So I was very happy when Zilby, who is a medium haired domestic medium hair cat, is what the vet says that most likely he is. And yeah, he's playing fetch. I've also got a clicker and I'm trying to like do some other training with him, but that's like, I don't know, I have to learn how to like properly do the training. But I'm hoping to like get him to do some interesting tricks. It'll be fun. I guess he's not coming back with the ball. He has sometimes in the past when he wants to play fetch, like long term, he'll bring the ball back. And there's been a point of time when I threw the ball, I like hit, like you can imagine, I hit like the wall, and so it didn't go very far, and he just sort of like turns and looks back at you like, really, you suck. All right, what are we doing here? So we've got avoidance working. Excellent. Avoidance is working. Is there anything you want to do to clean this up? Because this is pretty terrible looking. Let's remove some of these comments. Now I could create a helper function to do this. That might be actually really helpful here. So if we think about this is, okay, so we get the other location, get the distance. Like a lot of this is really just like this one long line of like getting this information. Locations. Okay, so we got the locations, we got the accelerations. This is fine. Then we loop through. Are you resetting the forces for each iteration? Yes. So it calculates the force here, and then the acceleration is reset every update. So I think update locations, we reset the acceleration to 0 every frame, and we're having 60 update frames per second. All right, I don't think Zilby's coming back, so I'm gonna turn off that cam. Am I using the force as a component? The force is a point, so I'm just using like a standard point as a force as well. Like it's basically like vector math. Oh, you meant in it as in an ECS component. In a way, yeah. So what I have here, let's go to the main library. So for each entity here, we have a location, a velocity, and an acceleration. We can almost imagine that the velocity and accelerations are forces. And so then each through I'm like adding forces to the acceleration force. and then the acceleration force gets added to the velocity, which then gets added to the location, and then acceleration gets reset to 0. So that's what's happening here. Now, so I don't know if I can like easily do anything here, but for you, so we cast location to get it out. The reason why I'm casting is because all of my components are enum components, because I was having trouble with, couldn't figure out like the proper way to use generics for this. And dynamic dispatch is possible, but I was like hoping to like try to avoid that. We might have to eventually, like for version 2, go back to that. But what I do, don't do that. It's like working as it is. It's just a little bit weird. So it's an enum as it is. So I can cast it from the enum component to the contained value of whatever it is. It's like a location in here we can see is a point with the actual data of the point inside of it. So I can cast to get out. So we get you out, and then we're using like RCs and ref cells for interior immutability, and that's what all of this mess then has me do, is like I clone the RC, so I get like another reference into it. I borrow it, which allows me to actually get inside of the ref cell. Dynamic dispatch and rest always feels wrong to you because you can get the benefits of static dispatch with the flexibility of dynamic dispatch if you're willing to fight with the compiler long enough. Yeah, absolutely. And I was reading through game dev patterns. Dynamic dispatch is one of those things where it can actually, like if you want enough things on a screen at the same time, dynamic dispatch is actually one of those things to avoid, because it takes up more resources per frame. And like we only have 16 milliseconds, and my idea is that I want these things to be able to run on a Raspberry Pi by the time I'm done with it. So we're gonna eventually like load up. I have a Raspberry Pi sitting like down here. I have this thing, and it's 16.7. 16.6 repeating. Yeah, exactly. And Raspberry Pis are like, for as powerful as they are as like little, $35 computers, they're also $35 computers. We don't actually have as much time as we think that we do. So it's interesting. Memory-wise, I haven't run into any problems. CPU-wise, I haven't run into any problems. Graphics-wise is where I run into problems. Is I need to like be as fast as possible to give the graphics as much time as possible per frame. And I might have to even go down to like 30 frames per second just to hit that. Now, I know there's other chips besides the Raspberry Pi. There's other ones that like might be better for this, but I think they're also more expensive. And I'm looking forward to like future versions of Raspberry Pi, because I heard that they're pulling in Apple and like writing their own CPUs, their own chips, which might even be even more efficient power-wise and just everything-wise. So that might be really cool too. But all right, so 16.6 also includes the cost of the draw cell. Yes, exactly. And GGEZ is great, but we did find that their draw calls is like surprisingly expensive. And the number of draw calls just makes it really, really, really expensive really quickly. But But using an ECS system like this with the different systems, I can work on never draw acid challenge the game. Sound only. You can't see the game. It's a graphic-less game. Yeah. That's what we want to do. Blank screen and call it accessibility. Yep. Yeah, there we go. Something like IoT games. I mean, that being said, games for people who have like sight don't have like good sight. That's an area where not enough people are making games for. But I know that people are making games in that section, in that sector. So it is cool. I haven't played any of them yet, but I've seen some of them out there. All right, so let's see. Now in here, what we're doing is we're guarding against if it's like not us. Then, okay. So other location gets this, get the distance like. Now I need this other location so that I can, oh, I don't need the other location. I really need the distance and the distance length. That's all I really need here is like this distance length and the distance. Now, what I can do is like, I'm only using this right here. So I can just do distance dot length like that. And that gives me a way of that line goes away. I don't need to clone you anymore. Because I have copy as part of it, so that's fine. We create this force, and then we multiply the scalar. Hello, Zilby. You wanna hang out? You want a pair? Yeah. I mean, it's an interesting idea, but I'm gonna go ahead and say that that's not part of my plan. Wait, Zilby, what did you do? Oh, I had like some balls here. Zilby just came up, stole a ball, and ran away. Hi. Yeah. Can you see? You can sort of see. Here, do you want this ball? Okay. Now right here, okay, so we're getting this force, and the entire reason for the force is to add in here. So I can probably create like an interior, like just a function. So function calculate force. We're gonna take in a distance, or maybe this is gonna be like create force. We're gonna take in a distance. And then we're gonna add that in here. That's all we care about. So we're gonna take in a distance, which is a point, and we're going to return a point. let me actually just do a reference to a point here. We're going to turn a new point. Points implement copy and clone, so this will be fine. It can just copy point during this here. Then we're going to create the force and return it. So then this is going to be like that force is equal to distance dot clone. Why are you unknown? And then force dot multiply. Oh, okay. We could take in the force, which is a point. So it's going to clone when we add that's in here. And we're going to say that you're a mute point. I guess just own you like that. Don't do anything like that. Now I can just say force dot. Okay, so I'm going to do these things. We multiply scalar. We normalize. We multiply by scalar. So now we're going to say, okay, so force is create force and edit in the distance. Can I find point in his scope? Then return force. Can I borrow? Okay, so your mute point. Where do I put the mute? Is it up in front? Oh yeah, it's up in front. Okay, so taking a force, and then do that entire thing. That's fine. So now we create the force here like this. So create force distance. Distance is cloned because it includes a copy, so it's copied. And then we just add you in here. So it's a reference to this. Now I wonder, can I just do a reference to create force, add the distance here, and remove you? I can. Okay, perfect. That actually removes a significant number of lines here and makes it a little bit easier to see. And if I want to like update you, like create the force, create force to move away, create avoidance force. So like tells us like a little bit more of like what we're doing. So now if we think about it, what are we doing? We're figuring out what the site range is going to be. We get our locations. We do our queries to get the locations and accelerations. We do, okay, so then for each location, we iterate through. We extract out our current location. Then we loop through all the locations again. If it's ourselves, we skip, get the other location, figure out the distance between the two locations. If we can see the distance, go ahead and add, like create the avoidance force and add it to our acceleration. So I think this is a much cleaner way of doing that. Let's go ahead and make sure that I haven't screwed anything up and it still works. It does. All right, everybody is trying to avoid each other now. Nice. Now the other thing that I can do is like I can try to make it farther away. Like what if I do like 120 and a really weak movement force, like 0.09, something like that. So it's like slowly moving away from each other. If they're moving like directly at each other like this, they're screwed. They're gonna run into each other. But this looks pretty good. Like they're getting closer to each other, and they don't take as sharp of turns anymore, which I like a lot. And we could maybe eventually like make this go full screen, and that'll be good. All right, is Kitty back there anymore? No. Okay, let's clean up some of these warnings. Don't need you. Don't need to clone on a copy type anymore. Acceleration, you need to be dereferenced. How I? So like power to an I-32. Yeah, go ahead and add it to this workspace. Each other. Really? You don't know how to... Okay. Each other is with a space in it. All right. No warnings. Everything should still run. So I'll leave that there. Okay, so BBECS, what did we do to you? We added the add assign and the sub. So updated the point for more math and push you up. Now for the flocking rust, voids are now avoiding each other. Well, trying to. Like sometimes they run into each other. I think that's gonna be fine. Okay. So what's next? I think next I want to do a really quick break because I ran out of drink. So I want to go get a new drink really quickly, and then we're gonna come back and figure out what the next thing is. So what I'm gonna do is let's just run this again. I don't think I have a way to like make this any bigger, so I'm just gonna move you to the center of the screen. I will be right back, and in like 5 minutes or less. So I'll just leave this up like this. See you in a couple minutes. Okay, I'm back and not muted anymore. Thank you so much, Epic Bark, for letting me know. Okay, so how do I want to do this? Alignment is next. So moving towards the same sort of like direction that everybody else is moving towards. So the idea here is, let's say we have our arena like this. We have, actually I think it might be easier to use this thing. We have a bunch of voids. I need you. Can I just not? The thing that I hate about like Windows Ink Workspace, it keeps on turning on. Can I like turn you off? It like screws up the oh wait. Okay, I didn't want that. Whatever that's doing, I don't like it. Ah, okay, never mind. I'm not using my tablet. Great. Let us figure this out. So we have like a void there, a void there, a void there, and let's say we are right here. So we're right here, and then our circle of influence, our sphere of like influence is right here. Now for each of these others, you're heading this direction. You're heading like this direction. You're heading like this direction. So what I need to do is figure out, I think it's going to be the exact same thing that we're doing. Oh no. How does this work? Okay, steer towards the average heading of local flock mates. So this heading is, it's a velocity, right? So I have a velocity of you, I have a velocity of you, I have a velocity of you. If I average those velocities, and then apply that as a force to myself, that might end up being something like this. Go that direction. So I want to get everybody else's velocities, average them together, and I'm good. That doesn't seem too terribly bad. All right, so pub function, alignment system. We're gonna take in a world. What do we call this? It's not world, it's like the world wrapper. I also misspelled alignment, so that's cool. There you go. Okay. Alignment system. We have to get our location and the other locations to be able to find the ones within our sphere of radius. Okay, that shouldn't be too terribly hard for us to do. So let's get our locations first. So locations is, and this is really like the wrapper. Locations wrapper, because like it's the RC, right? So it's equal to world.query1 component names location. that gives us this RC. I can now clone that for the locations. I want to loop through all of our own locations. So locations wrapper dot clone, that gives me my own locations. Then we're gonna go and iter. Oh, then we have to dot borrow to get just the vector. Then we can iter enumerate, and then we can get a for each. And so for this for each, it's going to be, let's see. What do I want to do for this? I'm going to get a index, and we're going to say like it's my index, and then my location. All right. Now that I have this, I have my location, I have my index, I want to get everything around me. And that's all I really care about. Now, last time I just did this externally. I wonder if I could do something like a function to sort of like get around me. So get like locations around me. So can I do something like function get locations around me? Get nearby locations. This is a functional function, so I need to pass in my location, which is going to be a reference to a point, and I need all the other locations. Functional function is near conjunction junction. Yeah. So this is, let's see, how do I want to do this? Get nearby locations. We need my location, which is a point. Unfortunately, I also need to do like the index, or to test equality. Maybe we can test equality. That might work. So if I come to up like a point here, for each point, we can maybe do like a partial equal. I mean, heck, we can even just do equal. I wonder if this would work. We can't do equal for F32s. Can we do partial equal? We can. Okay. Okay, so we can test to see if a point is equal to a point. And if it is, then okay, so this will work. So then we can do other locations is going to have to be a vec is a reference to a vec of point. See that. How am I going to do that? I need another one of these locations. I feel like this needs to be just this type. We're going to get a reference to an RC. What are you after I clone you? we'll go like this, and it will yell at me based on what's coming in. We're gonna return a vector of a reference to point. That's what I care about here. So then we're going to say that nearby locations is equal to get nearby locations. My location is easy. It's going to be my location is equal to my location dot cast point. So my location like that. Okay, then the other locations. So this is where we have this clone here. I want to take the locations wrapper and clone that, and then borrow it, which gives me something that's not this. Okay, so construct a ref. This is what I want. Okay. So then for each of these, I'm missing a lifetime specifier. I could clone them and they'll just be a vec of points. Maybe that'll probably be right. It's not the best. All right, what are you yelling about now? You're yelling because I didn't reference you. Okay, there we go. Okay, so get nearby locations. I want to loop through the other locations. So we need to loop through these other locations, which we already see is a ref of a vec. So I should just be able to start the loop through right now. So we could just do a other locations dot iter dot we could map, we could filter map. We can filter map. That's going to give us you. So it's going to be the other location. Other location is equal to other location dot passed into a point. Yes, I know. Fine, to do so you don't yell at me. You need to return like a sum or something like a sum or a none, based upon like whether or not you're you. Okay, so we have this point here. I could clone this point. That'll give me the point fully. Now I want if my location, but actually you're a reference. I wonder if this would work. If my location is equal to other location, return none. Right, okay, so that will then not be in this new vector that we're creating. Otherwise, I want to return a sum of just the other location to get these other locations here. So we're going to turn a sum of other location. What? How did I do that? Other location. We're going to clone you. I actually don't know if I need to clone. I might be able to just do this. We're going to turn you, and we're going to turn you. Okay. Return expected a vector of components point because of return type. I want a vec of point. What am I getting? Oh, I need to collect. That's what's happening. So collect this. Okay, so a vector of point cannot be built from iterator over a type of reference of point. The trait from iterator point is not implemented for, okay, yeah. Oh, so you don't know how to do that? Okay, so some other location dot clone. Using clone to copy type. Wait, but that worked. Oh wait, maybe we can clone here. Then I don't clone you. You dereference you. Okay, so you're just yelling at me. How about I dereference you? My location is a reference. What about you? Found a reference, so dereference you. Okay, no more yelling. That's happy. Okay, so get number of locations is now our nearby locations. So now we have a vector of points that are not myself. So we now have our own void here in my location, and we have all of the near, well, okay, this is just everything else right now. So we still have some more logic to do. So we need to determine like what nearby means. So this is where the like those other functions like getting the distance and like determining all that. Yeah, we still need to do that. A method would be nice here. A method on point. Like, so what if I had a method? Let's see, let's just do function distance 2. Takes in a reference to self and an other, which is a reference to self. And we're going to return an F32. So this returns the distance to another point, which it's another, it's actually distance to, yeah, this return an F32. It's like distance to another point. So looking at avoidance, it is, I guess it doesn't matter. It's other minus mine. So we're gonna do that distance is equal to other minus self. So it gives me a reference to a point. Then I want to take that distance and get the length. So distance dot length, like that, and we return that. And you need would that work? Can I actually do that? Can I do like impl sub for a reference to point? Is that a thing that I can do? Right now you're yelling at me about that. Sorry, dereferenced. Huh. I don't think I can. Okay, so this should give me the number of like what this is, a distance 2. So I should be able to come back to alignment, and if distance 2 is like within some amount, we're starting to like go towards each other. So let's do, all right, so filter map. Location is, so for myself, return none. If the distance to something is greater than a certain amount. So if my location dot distance to other location, if that is greater than, I don't know, 120.0, then return none. Otherwise, return the other location. So filtering out more. Now we're only getting like less and less and less of these inside of each of the points. Okay, that's fine. So now we have the nearby locations. What next? We need to now get their velocities. Oh, okay. So get their velocities. Actually, I don't care about the nearby locations. I want their velocities. That's going to be interesting. I wonder if I want get nearby indexes. If that would be, if this would be correct. So get nearby indexes. I'm, instead of like returning the standard, like all of this stuff, I'm returning a vector of usize. We're going to iterate dot enumerate. Going to give us the index and the other location. Return none. Otherwise, return a sum and the index. And so this is going to give us now the index of what we're looking for. So get nearby indexes. All right, so once I have the nearby indexes, the next thing I want to do is get through for every single, we need to like get all the velocities together. So I need to do a let all of the velocities. So that's what we need is nearby velocities is equal to probably like get velocities by index. So we need to pass in the velocities, which we don't have yet, but we'll get them. And we also need to pass in the nearby indexes for those velocities to get. And that's going to get me this. So you're obviously going to be upset a little bit, just a little bit. Just a teeny tiny bit. Let's get the velocities first. Nearby indexes is going to be easy also. Let's go ahead. It's going to be a function, get velocities by index. Okay, so what are we getting first? The velocities. That's going to be something similar to this. So velocities is going to be a ref of vec of these components. Okay. And then the index is going to be a reference to a vec. I could actually give ownership of this. I'm okay. Like once I'm done with this, I'm done. So we can say a vec of usize. And you're the indexes. We're going to return a vec of point. Right. Now you're just yelling at me that we haven't actually done it yet. All right. So now you're going to yell at me that we don't have these velocities. So let's grab them. So we have let locations wrapper to grab this. Let's do let velocities is equal to world query 1. And you're a reference. Okay, so that gets this. Then we can just borrow straight from here. All right, so that gives us a ref of vec of component, which is ref of vec of component. Exactly what we were thinking of this. So we can now pass in velocities. Cannot move out of velocities a captured variable. Move occurs because velocities have type. Does not implement the copy trait. Oh, interesting. Okay, because I went this for each. The nice thing is I don't need to borrow here. We could just have this be a velocities wrapper. And once again, I don't need to mutate the velocities. That's what acceleration is going to be. So we grab this velocities wrapper, and I want to now take velocities wrapper, which will clone for me. So now we want you to be... I can now borrow inside of here. That's what I do. I borrow inside of here. Okay, so now you're happy. We have you coming in. We have the downcast. Do we have the downcast? We have the velocity. Okay, so we have to loop through all the velocities. So it's gonna be another filter mute. That's what I'm seeing here. So we're gonna do a our filter map, I think. So velocities dot iter dot enumerate dot filter map. We're gonna get the index. And we're also gonna get the velocity, which is this component. All right, so first things first, we don't care if this index is inside of this index is, we're done. Like we can return a none. So if index is dot, what is in here? Is there like a find or like includes? I think there is something like that, but what do I need to find? Like, what would it be? I don't see like an includes. Let's see, probably not find, maybe get. Let's go all the way up to the top and go through one at a time. Contains? Let's see. Contains. Returns true if the slice contains an element with a given value. Ooh, I like that. Okay, so if index.contains index. Okay, so if it contains this, then we want this velocity. So we're going to return a sum of a velocity dot cast point. We might have to clone here. Otherwise, return a none. And then collect. Mismatch types expected. A reference to usize found to usize. Don't need to clone you because you have the copy trait. However, I mean, clone, copy, just go ahead and do it. Okay, fine. Clone you. You yell at me, but you work. Yeah, you're not an error. Oh, try dereferencing it. That's what I need to do. Oh, okay. I need to dereference it like that. Okay, so that gives me an actual point now. It copies out. So then we have the get velocities by index that we care about. So near velocities equals get velocities by index. Okay, we're good to go here now. We now have a vec of points. Excellent. So now I want the averages and single average point based upon all of these velocities. we can do another function for this, but the idea would be let the average velocity is going to be equal to like a calculate average velocity, and we're going to pass in the nearby velocities. And we can give ownership of it to that because we don't really care. We're done once we have the average velocity. So velocities is going to be equal to a vec point, and we're going to return a single point. Yeah, I don't know if this should be like a static method essentially on point. Like maybe it should, and I can pass in the velocities there. I don't know. That might be interesting to do, but I don't think it's necessary either. All right, so calculate the average velocity. What I'm going to do here, I want to essentially do like the idea of like a JavaScript map, like reduce. We want to turn all of these into a single. Well, okay, it's not that simple, is it? Two things. We want to sum them together, like add all of the points together, and then we want to divide by the amount that the number of these velocities. Well, we have the number of velocities to do, that's right here. So we need to add them all together, which would be like the equivalent of a reduce, which I think, like, so let summed points is equal to velocities dot that. I think it's like iter. There is something here to do, and I forget. It's not reduce, it's something else. It's not flatten. Oh, is it fold? An iterator method that applies a function producing a single final value. Fold takes two arguments, an initial value and a closure with two arguments, an accumulator and an element. This is what it is. It's going to be fold. So fold, our initial is we're creating a single point out of this. So we're going to start with a point new 0.0, 0.0, and then our function, which is going to be our velocity. You are two things, I believe. In this function is yeah, the accumulator and this. So the this is basically the sum and the velocity. You're unknown. Why is that? And then I do want to return this, so that should be fine there. Expected a semicolon. Oh, because I want to just return you at the end. I'm kind of sad that it doesn't know what these are. Hold. What are you upset about? Oh, it's 2 arguments, not a tuple. Okay, that's what the problem is. That's what the problem is. Okay, so we have this sum, which is a point. You need to be mutable so I can update you, and a velocity, which is a reference to a point. Okay, perfect. Now, what I want to do is I want to say sum dot add the velocity, and then return sum. Okay, so we add the velocity to the sum, and then we return the sum. At the end here, oh right, let summed velocities is equal to u. It's a single point, semicolon u. Now I want to divide this by the number of these points. I don't think we have a divide. Like we have this add a sign, we have this sub. We don't have that. So let's now impl div for point. Output type. Okay, so it's self. We'll just, I like this to be like other. Okay, so we're gonna report a self, which the x is gonna be self.x divided by other.x. Y is self.y divided by other.y. All right, so coming back to here, so now I want to, oh, I don't want you to be self. Oh, right. Is that true? I want you to be a scalar. So like, I want you to be like an F32, but I don't think I can do that because you're gonna be, yeah. How do I add that kind of thing in? I want to say like impl divide for like F32s. I don't think I can do like an F32 here for point. I don't think that works, right? Okay, so output is gonna be a F32. No, it's gonna be a self. Ah, okay. I like this. That's how, okay, that's how I do this. This is gonna be right-hand side. Then we're gonna do a self. X is gonna be self.x divided by RHS. Y is self.y divided by RHS. There we go. Okay. So now I can do some velocities divided by velocities dot length. Oh wait, length isn't F32, is it? It's a U size. Well, U size. And then RHS is as F32. Because of reasons. That's probably not a good idea. I can't imagine that's not going to confuse myself at some point in the future where I'm like, why? All right, but no errors. So calculate average velocity is now like we have this point, which is the average velocity. I want to take this average velocity and just add it to my own as a force. Which means I want to normalize it and then move in the same direction. Otherwise, I'm going to speed up way too much. So actually, I wonder if I would speed up too much. Anyways, we need to get the let accelerations equal to, and you need to be mutable here. World.query1 acceleration. Okay, so we're going to get our acceleration. Then once we have this average velocity, which is essentially a force, I want to now add it to accelerations. So we're going to say accelerations of index. It's going to give us the component. We're going to, oh, we need to borrow mute you also right here. So index, oh, is my index. I'm going to cast point mute. And then we're going to plus equals the average velocity. Oh, we have add assign. We have add, so we can just do add average velocity. And you need to be a reference. You need to be a reference. I mean, there's no errors. I'm curious. Oh, wait, I can't test it now. We're not using it yet. So alignment system, we need to go into the main library. So we have our avoidance system and now alignment system. Pass in a reference to self.world. All right. What is the chance this is going to work? What do we think? First try. Haha. What happened? I'm guessing that force was way too big and they just took them all off the edge of the screen. Like they're gone. They teleported essentially. So I think like before I do this, I do need to get this average velocity. We need to mute it. And we need to do like our standard things to it. We need to average velocity dot normalize average velocity dot let's see what else. We need to multiply a scalar to it of like 0.1 and then we can apply it. Let's just try it again. Oh no, they're still gone. What did I do wrong? So add this average velocity. We normalize, we multiply it by a scalar. Like, what if I go really, really small? So like you're barely doing anything. Okay, that's not a good sign still. What if I just don't do you? If I, like, this shouldn't be doing anything, so everything should still be exactly the way it was before. Yeah, okay, so here we are. They're all avoiding each other. They're nice and happy. They're getting everything within like 120. Might be too much. Like, let's say we do 50. I kind of want to make sure if I debug the average velocity, I hope that you're like not something like not a number. I'm afraid that's gonna be not a number because like the divide, it might be like 0. We had that before. Yeah, look at that. So okay, stop. Nan. Okay, so what's happening here? We're dividing by velocities.length, which might be 0. So if compute average velocity, if I compute the average velocity and there are no average velocities, so we need maybe to check here, like if there are no average velocities, we should just double check, but I think that might be the problem, is like some of these don't have them. Okay, oh, back to here. Down to here. Let's debug velocities.length. I want to say that we're going to get like a bunch of zeros. Yeah, zeros. We have some numbers that are like not zeros, and that's fine. That's great. Unfortunately, we need to only call this if our calculated average velocity is greater than 0. So we get our average velocity. We only want to do this if, so if average velocity dot length, no, it has to be above here. If nearby velocities dot length is greater than 0, then go ahead and do all of this stuff. Otherwise, we're not doing it at all. I mean, I feel it's looking slightly different than it was before, but also like I'm never seeing this number. Okay, every once in a while it goes above. Are they sort of moving towards each other? Maybe not. I feel like because, let's see, get nearby. Okay, so nearby is 50. The problem for this is avoidance is 120. So I think I kind of want to make you down to like 25 and then 50 here. So you're sort of, are you gonna start moving together if you're close enough? Yeah, you kind of move together, and then you see each other and you're like, whoa, nope, get me away from you. So we need to sort of like tweak some of these numbers just a little bit. So get nearby interests for you. Let's do like you are 100. For avoidance, 25 might be good. And I think I might need to like increase you to like 0.25. So they are kind of moving towards to. But then they get too close and they sort of bump off and you're like, nope, screw you, and I'm going away from you. So I wonder if I want to, like, for alignment, we have 25 where they move away from each other. And I want like you to be like 150. Or maybe 100 is good, but our steer needs to be much stronger than this. I'm basically not steering it like 0.001. Oh, look at that. Look at that. That's practically an entire system now. They're successfully avoiding each other and move. Okay, so I need to stop this log because that is killing performance. But that looked much more impressive than I thought it would. Okay, let's try this again. Wow. Like, I didn't think it would just suddenly start coming together like that. I love like when they get to the edge and they all turn, but they also like they're doing a very good job at avoiding each other. This is pretty cool. I like it. This is actually kind of fun to watch. They're all eventually going to create like a super group. But all right. So learnings from this one. Breaking everything out into functions, so much nicer than our previous avoidance where everything was pretty much in one function and we just have a bunch of this logic here, which is not the easiest to follow. Here with alignment, I'm able, like, it's still not like less length here, but I can see what I'm doing based upon like, okay, get the nearby, then you just like filter out, get the ones I want. So it's like doing more complicated stuff, but at the same time, it's not any harder to read. Length comparison to 0. Oh, use is empty is clear. Okay, so use just is empty. So use not nearby velocities dot is empty. That. So I think this works pretty well. Let's go ahead and clean up all of you. So we don't need you. Oh, what am I doing? What language am I writing? Oh, I need to probably do that. Okay. Alignment. Okay, so I need to respell you. That. Yeah, and Rest Analyzer auto fixes the spelling everywhere, which is great. Unresolved import. Wait, I thought I fixed that. Alignment. Wait, you're all. Oh, I need to save it. I need it. It updated everywhere, but it didn't save the files automatically. It sort of like made me do that. But okay, everything is saved. Let's go ahead and run this again. Make sure it's running. It's amazing how when I have only like 25 together, but they're all sort of randomly going everywhere, it looks really crowded. When I have 25 and they're moving based upon alignment, suddenly it looks like we have just so much more space. Yeah, it does look really cool. Let's see what happens if we add in a bunch more. So right now we're creating 25. Let's try 100. See if we can handle this small arena. I mean, there's a little bit more collision type things as they freak out, but they're still trying not to, which I think is great. And it takes a little bit longer for them to align together, but they do pretty quickly. Can I run in release mode? Absolutely, yes. So cargo run, release. It's almost there. All right, here we go. Cargo flame graph for the win. Yeah, I've oh, that cargo flame graph, that's the one. Peyton, I think you were talking about how to find out like any optimizations that we need to do. I think cargo flame graph is that library that I had heard of. I have never used it though. It would be really nice. You should run this in a profile at some point. It would be interesting to see where it spends most of the time. Yeah, that would be interesting. We have more systems we have one more system to create for it. And then we can do that. See like where it spends the most time. Can flame graph also like do a memory analysis? So this is pretty smooth still. I'm curious what our FPS is, like how good that is. Let me think about it. I don't think so. I think flame graphs is only time spent graphs. Okay. It's probably not that big of a deal. There is a lot of copies, but let's see. Let's try 1,000. 1,000 is small cycle. Yeah, it's gonna get a lot more trouble here. A lot of trouble. This is like 2 frames per second, maybe less than that. Okay, so 1,000 is maybe a little bit optimistic. Let's go 250. 250 is still pretty smooth. Now, things that I can do to optimize. Every single Boyd is checking every single other board in the entire, world, which is really unoptimized. So if I had like a graph system where every Boyd could only check the Boyd near, like that we know is nearby them, that would be a great optimization right there, and just like immediately reduce the number of loops that are happening, because that is pretty bad right now. That being said, 250 of these on the screen at once is not bad at all. I feel like they just want to be together a lot more. I wonder if I could. We can come to main. I know that there's a way to do. Is it window mode? It looks burby? Yeah. Let's see. Window mode is equal to. Yeah, window mode. Default. Dot. Oh, right. I keep on forgetting it's like it's what's the dimensions? Set the default window size. That's what it is. So dimensions. And then if I want something like 1000 by 1000, and need to be F32s. And then here, so we have context builder. Then before build, we can then do a dot window mode. So if I do that, look at this difference between release and not release. It can't handle the 250 at all. But in release mode, it's fine. All right, so I can make this like plenty big, and it just handles. It looks a lot better here with this size. So there we go. We have two of these hanging out together. Let's send this all up. I'll leave you over here. Okay, BB ECS. We did make one change to you. We added the distance too. So added distance to and ability to compare points. And push that up. Then we have you. Okay, so voids are now steering in the direction that nearby voids are traveling to. Okay, I'll push that. Now, looking at the Wikipedia page, cohesion, steer to move towards the average position center of mass of local flock mates. That's going to be the last thing that we do for this. And then once we have that, we'll be done. Like we'll have a flocking simulator. Actually, like it already looks pretty good for flocking simulator, but I think I think that will be the last little bit of it. And then I'll have to check my own personal requirements for this to see whether or not like what other things I need to add in. I think that I added in that I wanted to like be able to resize this on the fly. Right now we can't do that. We'd have to like change some settings around. But once I have that, then we'll be able to like mark this as completed. So it is 11:43. I don't have time to add in that new the new feature yet. So that's gonna be starting tomorrow morning. So I'm gonna go ahead. Let's see. Tomorrow morning we'll start working on the steering towards like where everyone else is. So what is that? That's the average position of local flockmates. So it's very similar to what we have here. It's just slightly different. Let's see, what else do we... Yeah, that's pretty much going to be it. I'm streaming every single weekday morning at 7 a.m. Mountain Time. And then on Sundays, a little bit later in the day start. Usually I let myself sleep in just a tiny bit. And then we're going to continue working on this. And then after that, I'm not exactly sure what we're going to work on. I'll have to sort of think through it. But with that,